So the first step is going to be turning on the BallyBot. I'm going to hit the switch on the side here. See how I can connect. I go to the Wi-Fi, and I should see the BallyBot as a visible network. There it is, and I connect. Once it's connected, it'll open up a capture portal, and that'll just basically open up the website on its own, and I can drive it now. Hi there, and welcome to the BallyBots devlog. Here, I go over updates, problems, and my progress through them. I'm designing a streaming, web-controlled robot, and my goal is to make it as accessible as possible. Funnily enough, accessing the robot in an intuitive way is one of the hurdles I struggled on. Robots almost always need internet to send out the data, and especially in our case, where the video streaming, settings, and controls are over Wi-Fi. So, most companies come up with their own way of connecting to the robots, usually in the form of some app. You'll also see interfaces directly on the robot, or QR codes that it scans to get on the internet and then controlled from there. Unfortunately, none of these options are really that accessible. I mean, imagine being at a party and trying to convince someone to download an app. Or possibly more confusing, trying to find a QR code generator to have the robot scan it. No, I really can't expect someone to take more than 2 minutes to get this thing working. The first place I ended up looking was at the Esp32 examples, which is what I've built my board off of. And what you'll find in there is the demos on access points, which are very much like hotspots, except they don't relay internet necessarily. And what happens is the robot makes an access point. You see it as a Wi-Fi network you connect to, and your laptop can then directly connect. This also works on phones. It's pretty much just like connecting to your router. And there are a couple big advantages to directly connecting this way. You have super low latency, you don't have to download anything, and it works without an existing Wi-Fi source. I really cannot understate how useful working without internet is for this robot. It lets you go to parks, conventions, and any building in general that you're unfamiliar with. But this is still not enough to meet the goals of BallyBots. If I want to call this a telepresence robot, I need to control it from an arbitrary distance away. So, the next step is to go between this AP mode and the server mode from my previous videos. For those curious, the BallyBot server mode is built on top of the Esp32's station mode, where the board connects to a router for access to the internet, like a normal computer this time. After this, it looks for the server IP to form a WebSocket, and the server relays that information to any subscribed clients. In other words, the laptop. So my last big step is to make it so that the BallyBot can switch between the AP mode and the server mode and change the way that it's configured in the network. One of the biggest helps I had in making this was a demo I found on GitHub by yash-sanghvi that went over how to make a access point switch to station mode when the Wi-Fi network fails, and that way you can type in the Wi-Fi and connect. After I glued that into my code, I now had it where I could hit a button and I could enter my Wi-Fi username and password, and then I'm connected to my router. The BallyBot starts a WebSocket pinging the server, and then the server has a for loop that iterates through all the WebSockets, and it sees if a client, a laptop user, is connected to the same ID as a BallyBot's. And if so, it starts relaying that info, and it's pretty much done from there. The code for this project is open source, and you can find it on my GitHub, which I will link in the description. So that's the end of the video. I'm planning on making more highly edited devlogs like this, so if you liked it, go ahead and subscribe for more.